All right, so let's start chapter 4, Newton's laws of motion. Very interesting, very nice chapter. Again, it's gonna be easy to understand as well. So Newton's laws of motion, we'll try to explain motion. Probably you might have said like, but we have been explaining motion so far. Yes, without its cause. Without its cause. So in chapter 2 and 3, when we were talking about like motion, we are trying to describe, the car is traveling at this distance with the initial velocity of this much, and so on and so forth. But we weren't saying much about like what is the driving force behind it, right? So we didn't say much about that one. So in this chapter, that's mostly the objective. Okay, we'll try to describe motion using Newton's 3 basic laws. Okay, so there are history of motion, like the Aristotle, for instance. They were mentioning like objects may be pulled or pushed to a near location. Then he said when there is no force applied, then it stops. Okay, and then he mentioned that like a rock falls more rapidly in air than in water, and most of Aristotle's version of like theories or something like that, mostly they're based on conversation, based on his observations. Okay, so now the question is now, for instance, according to Aristotle, then what if, look, according to this theory, according to the very first statement that you see, if you throw a ball, just imagine you're throwing a ball, right? So if you throw a ball, when do you apply force? Right at the beginning, right? Then there is force. Then after you throw the ball, right, at the beginning, but the ball will keep on moving. But according to Aristotle, what he was saying is like the ball, as soon as the force being applied stops, the object stops. Well, that's how he said it. Then his idea of like why a thrown object keeps on moving, he was mentioning something like, oh, when the ball passes through the air, it's making the air to move like this, and the air is going to come up in the backward direction, and then it's pushing the object, and then the object like that keeps on moving. The air vacuum that creates it, then it keeps on pushing it. That's what he's saying. Okay. Now, but that's always true. Is that normally the case? Okay. Probably not. Okay. Then there was a Galileo kind of theory, and like what he said is like the natural tendency of an object is to continue moving, like because unlike the Aristotelian, like he tried to have some kind of better understanding. When you throw the object, right, with a certain force, this object starts to move. and then its natural tendency is to keep on moving. If the object is sitting, it means like if an object is sitting, then its natural tendency is to stay seated. Okay. So then Newton came into the picture. He took those two ideas, and then he developed like his own theories about motion. Okay. Then of course those are the most, you know, they are the accepted and proved scientific concepts. And so before we go ahead and then further, let's define force. What is force? We're going to talk about like force. The cause of motion is force somehow. Okay. So therefore, how do we define it? Like in layman terms, like force is a push or a pull on an object. Okay. It's a push or a pull on an object. And a force can be a field force, like for instance in a magnetic force, a gravitational force. A field force is like, well, sometimes even though there's no any direct connection or contact between the two objects, if you bring two magnets close to each other, they push and they pull to each other, right? Earth's gravity is a field force. You throw an object in the upward direction. There's no any direct kind of contact between the Earth and that object, but the Earth pulls it down because of its gravitational force, because of its gravitational field. The other one is like you pull an object, that's a contact force. You kick a ball, that's a contact force. Okay, so just to make it simple, like force is a push or a pull on an object. Okay, so you know, based on those Aristotle and Galileo concepts, and then Sir Isaac Newton, he formulated like the three basic laws of motion. The first law of motion says an object remains at rest or in motion on a straight line unless it's compelled to change by an externally imposed force. Yeah, it's you know, an object stays at rest, would like to stay at rest. An object in motion would like to stay in motion. That's what in simple terms, that's what Newton's first law states like. So you have an object, you push it, then it would like to keep on moving unless an external force acts upon it. You may say like, oh, but yesterday I rolled the ball, I kicked the ball on the ground, but it went in a straight line, but eventually it came to rest. So you may say like, doesn't this really like somehow oppose the concept? Not really, because there is opposing force. When you kick the ball, there is something, we call it friction, between the ball and the surface that slows down the motion and eventually brings it to stop. Okay. So force is a vector quantity. Okay. A vector quantity. So keep it in mind, direction is important. Then when we talk about force, then at some point we need to talk about like the masses of the objects that we're dealing with. So mass, what is mass? Mass is the measure of inertia of an object, and it's a scalar quantity. Its SI unit is kilogram. Okay. Force is a vector quantity and its SI unit is Newton. Okay. Its SI unit is Newton. We'll come to that one a bit later. So you may say like, if mass is the measure of inertia, then what is inertia? Inertia means like, if you look at this animation, look, when the car comes to a sudden stop, or if you are in a car and all of a sudden like the driver slams the brake, what would you do? What happens to you? You move forward, right? You lean forward. That's because of inertia. That's the tendency. Inertia means the tendency of an object to stay in its state of motion. Your tendency when the car was moving was like your tendency was moving. When all of a sudden, like when the car brake is slammed and then you come in to rest, you lean forward because your tendency was moving. You want to keep on moving. Okay? You want it to keep on moving. That's what the natural tendency is. So the second law of Newton is known as Newton's second law. Newton's second law involves a formula that looks like a basic formula, that looks like very simple kind of formula, but very essential in physics. Okay? It states that like the acceleration of an object is directly proportional to the net force applied on it, but inversely proportional to the mass. What does it mean? Like, that means if you take two objects, like this is, let's say, 10 kilograms, and then let's say this is 1 kilogram, then let's say you apply 10 newtons of force. You do the same thing here, apply 10 newtons of force. This object was going to accelerate with 1 meters per second square. This object will accelerate with 10 meters per second square. If you apply the same amount of force on different masses, the lighter mass will accelerate faster. That's what it means. Yeah, you can feel it. If you kick a soccer ball and a bowling ball at with the same amount of force, the soccer ball will move faster, even though you apply the same amount of net force on those two objects. Because acceleration is inversely proportional to the mass if you keep the same force. Okay? But if you increase the force, then the acceleration will also increase. Okay? Then if you look at this equation, it's a very interesting equation. Like, so you can have the variety of that Newton's law. What will happen is net force. Why do we say like net force? I'm going to come to that in a moment. Then it will be mass times acceleration. Why do we say net force? Like, if you take two, like if you see a table, like for instance, you are pushing the table with 10 newtons of force in this direction. Your younger sibling is pushing the table with 5 newtons of force in this direction. Eventually you are applying a lot more force, then the object will definitely start to move in this direction. But by how much? The net force experienced by this table is what? It's gonna be 5. Because it's going to be 10 minus 5. Because you're trying to move it in this direction, but your brother wants to move it like in the opposite direction. But instead, like if you two cooperate and then start to push this object in the same direction, you apply like with your 10 newtons of force. Then your sibling helps with 5 newtons of force. Now your net force is going to be, because this object will also move faster, then the net force in this case is going to be 15 newtons. The sum of the two. Okay, that's what it means. Like when you say like, what do you mean like net force? What I mean by net force is like what if you have multiple forces? What if you have multiple actors on the object? Multiple things act on the object. Then how do you find the total force? That's what the net force. We don't use the term total because if you just simply lump sum it, you get 15 in here, 15 in there. but the impact is called Newton. Like net force means the impactful amount of force. Okay, you can put it that way. We already mentioned like the SI unit. The SI unit of force is Newton, and 1 Newton is equivalent to 1 kilogram meter per second squared. Why? I mentioned this. Net force is equal to mass times acceleration, right? The SI unit of mass is kilogram, and the SI unit of acceleration is meter per second squared. Okay, the combination of the two. The combination of those two units has special name known as Newton. Okay, Newton. In a US customary, it's measured in pounds. Force is measured in pounds. Then 1 Newton is equivalent 0.225 pounds. Okay. I encourage you like to go through the example boxes for 1 and for 2. Then from there we'll continue our next lesson. Okay. Until then,